Alrighty, good morning everybody and welcome to the wolfSSL Live Partner Webinar with ISRG with cURL founder Daniel Stenberg and ISRG engineers Sean McArthur and John Oss. My name is Kajal Subkota and I will be moderating this webinar. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hands to be unmuted if you would like to ask the question live, as we do host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. We also provide slides for the webinar upon request. I invite everyone to follow us on Twitter at wolfSSL and at ISRG, as well as all of our other socials. Please feel free to email us at facts@wolfssl.com if you have any additional questions. And now I'm going to hand it over to Josh for the technical presentation.
Hi, my name is Josh Ose. I'm with Internet Security Research Group. We're best known for Let's Encrypt, but we also have a memory safety initiative. And the work we're going to talk today came out of that initiative. So I'm excited to have Sean McArthur with the Hyper project here and Daniel Stenberg from cURL. So like I said, I'm with Internet Security Research Group. We're a nonprofit, and we really just want to make the web a safer and more privacy-respecting place. We're best known for Let's Encrypt, which is a certificate authority that helps websites enable HTTPS to protect their visitors. We serve now, I know the slides say 225, I think we're around 240 million websites today. So we care a lot about security, but it goes beyond just HTTPS in the web. There's a lot of fundamental software out there like cURL that we'd like to see become more secure. So the problem that we're trying to address here is memory safety. And a lack of memory safety in a lot of the internet's foundational software is a real problem. The languages that are the biggest problem are C and C++. So when you write code in C and C++, it's very hard to not make mistakes, even if you're a pretty excellent programmer. The languages are just sort of inherently unsafe. So we discover new vulnerabilities in C and C++ in foundational software of the internet every day. And it's something we need to try to do something about. So these problems exist in web browsers, servers, proxies, business logic, crypto, kernels. Every part of the stack has this stuff. We've been suffering from these vulnerabilities for decades now, and we're going to continue to suffer unless we do something about it. So Microsoft estimates that about 70% of all vulnerabilities in their products over the past decade have been caused by a lack of memory safety. You know, Google says about 90% of the Android vulnerabilities are due to a lack of memory safety. It's just a huge problem that is out of control on the internet. And there are real costs, right? This isn't just like theoretical CVE vulnerability postings and like patches that come in every once in a while. These things lead to privacy violations. There's huge financial losses as a result of these things. Because they enable certain types of attacks and viruses. There's denial of service, including to public hospitals, power grids, things like that. And there's human rights impacts. So people who are out there trying to change things for the better can often be targeted using these kinds of vulnerabilities. So there's a real price to society that we're trying to address here. The good news is we know how to solve all this. It doesn't have to be this way. We don't need to invent a clever, new solution for how to avoid memory safety problems. We know how to solve this, and we have the tools out there. Unfortunately, the tools, I think, took a while to be developed, but they're here now, and we want to see people make better use of them. So there's some mitigations that we can do to help make C and C++ a little safer, but ultimately it's not going to be safe until it's just replaced. So our initiative is to replace the code that isn't memory safe with code that is. It is going to be a lot of work. This is not something that's going to happen. It's not going to happen this year. It's not going to happen in the next 5 years, maybe not even in the next 10 years. But the internet is not going anywhere. It's going to be around for a long time. So when we make investments in solving a problem like this over the next 5 to 10 years, there's a long time for that investment to pay off. So yes, it's a lot of work. Is the idea of replacing the internet's foundational software in C and C++ with memory safe code? Is that it sounds a little bit crazy, but it's not. It's totally doable if we get to work on it. So our initiative has two goals. Like I said, to move the internet software infrastructure to memory safe code. But there's a second one to change the way people think about memory safety. Um, you know, we live in a world where deploying C and C++ on the edge of your network to handle a bunch of network traffic is not seen as crazy or irresponsible. It's just something people do every day, despite the fact that we know how dangerous it is. So we want to change the way that people think about this stuff so that they really understand that the risks that are being taken when we use C and C++ in this way. And my hope is 10 years from now, people think about doing that and think like, no way would I ever do that. That's obviously not safe. So ISRG's role in all of this, we work on some strategy. How are we going to tackle this problem? Then we facilitate and coordinate with the different parties that need to be involved. We help fund the work, and then we help communicate about what's being done. Sometimes our engineers do some of the work, but mainly we're trying to enable community and maintainers to do the work. This isn't something that our own staff could make a dent in just by writing code. So we need to get a bunch of people involved in this. So the first step in our approach is to identify projects that have the best return on investment. So we want to focus on projects where if we can improve security a little bit, it's going to have the biggest payoff for the most people. So we want to look at how many people are using a piece of software, how security sensitive is it? So I think one thing we think about is that things that are on networks, and especially untrusted networks like the internet, those tend to be a little more security sensitive. Are there, are there things about the project that make it easier for us to make a difference? So for example, are there places where we can swap in a library relatively easily and get the best payoff for that input? And then we look for projects where the maintainer or the project in general are cooperative and want to go down this road. We don't want to fight with anybody about what to do, and having people who are on board with our mission really makes the investment much easier to make. And on that note, we want to work with maintainers wherever possible. Maintainers have really valuable knowledge, and they have the ability to ship memory safety updates to their existing users. If we have to replace a piece of software and get users to move to using a different piece of software, that is much more difficult. First, we may have to build that competing software, and then we would have to get users to switch. And all of this is much more difficult than just working with maintainers to help improve existing software. And also, when we can work with maintainers, it helps to create buy-in for the project, and it helps to alleviate resource concerns. I think any open source maintainer will tell you that they get a lot of requests from people saying, you should do this, you should do that. And very few people are willing to step up and say, I'm willing to fund this. I'm willing to support this work in one way or another. So we want to make sure that maintainers feel supported in the work that we're suggesting that they do. The third thing is we look for a modular approach. So rewriting pretty much any piece of important software is almost a non-starter. If we're, to just rewrite that from scratch would be too much. So we look for software where we can take a modular approach and say, let's replace this piece of functionality with this memory safe library. And then when that's done, we can move on to this thing. That makes it much easier to tackle the work. And it means that we can deliver value incrementally. So, for example, we're talking about curl today. If we insisted on rewriting curl entirely from scratch in a memory safe language, A, that would probably never happen. And B, even if it was something we're trying to do, nobody would see that for, 5 years or 10 years or something, who knows? But with a modular approach, it's easy to do one piece at a time, and users can have the benefit of that work being done relatively quickly. So the work we're going to talk about today, it happens in well under a year, and people can benefit from that work, starting today. And the last part of our approach here is to build trust by providing additional success stories over time. So when you go to maintainers who have been working in C and C++ for a long time, and you say, hey, we think it's time to make a change, at least in certain components of your project, it understandably makes them nervous. Like, what we're asking is not a simple or an easy thing to do. And we want to show them that there are ways to do it that work for different projects, that are not overwhelming to the maintainers, that people are getting the support that they need, and that the users of software are happy, and that there are strategies to sort of maintain compatibility and address all the other concerns that maintainers might have. So, one of the reasons we really love working with Daniel is that, we don't have a lot of these success stories yet because we're just getting going on this, but Daniel understands what's going on here, and the work that we're doing with him is going to provide a great story for us to help when we're talking with other maintainers in the future. So why did we pick curl for our first project? It really hits all the criteria really well. So first of all, curl is everywhere. It's a great return on investment for any security improvement that you can make. Second of all, Daniel's a great maintainer to work with. I already said a bit about that, but he understands what we're trying to do. He understands why it's important. Third, curl is modular. We can do this one piece at a time. And the last, this is going to be a great story going forward. So I want to thank Google for funding this work. We weren't able to have somebody on Google on the call today, but the reason that they're funding this work is because this aligns perfectly with their strategy and their approach to security and open source. And they understand that we can't fix security bugs one at a time forever. We need to solve classes of problems and eliminate classes of security bugs, and this is how you go out and do that. So I want to thank Google for funding this work. And I also want to thank Daniel and wolfSSL and Sean and his work on Hyper for helping us build a safer future for curl. So I'm going to turn it over now to Sean McArthur with the Hyper project, which is the HTTP library that curl is going to be using.
All right, there we go. Zoom, how does it work? I don't know. We're all set here. All right, so I'm Sean McArthur. Like you said, I'm author of Hyper. So let's get into this. How do we make you work? There we go. So what are we going to talk about today? My little slice here. Going to talk about what even is Hyper. Why does it exist? What is it? Why did we even do this? Josh explained a bit about that. We'll talk a bit more about the benefits. Talk about what we actually did, making a new C API so that curl could make use of Hyper. And also mention some of the few things that we still need to do. We're not done, but this is exciting progress. So first up, what even is Hyper? And besides being some HTTP library, in case you didn't know, it is an HTTP library. But what makes it special? Well, it's written in Rust. Why did we pick Rust? Why did I pick Rust? Well, it's as fast as C or C++. Josh mentioned this a little bit. The important part is that it's also memory safe. So you can, usually you have that mechanism of, you can either go fast or you can have safety. Pick one or the other. And Rust, says you can have your cake and you can eat it too. You can do both. And so that's why I ran into Rust. I wanted something fast like C, but I didn't want to shoot off my foot by writing memory unsafe code. And then I have here, many times I say I came for the speed. I stayed for the type system. Eventually learning the type system, I found there's very few languages that allow me to put so much into it. You can encode so much of the logic into the types. Your compiler will catch you making mistakes, and they cost nothing at runtime. There's no like implicit boxing that you might get in some languages where every time you create a new class, you've made more allocations or something like that. No, it all just kind of disappears. More like structs in C, really. There's fantastic parts like new types and some types. Traits are a pretty different way of thinking about things as opposed to object-oriented inheritance. And so I was super excited to get into Rust. And the first thing when I found Rust a few years ago, I wanted to write server stuff, and that stuff didn't exist yet. So first things first, had to make an HTTP library. So I made Hyper. Hyper has a client, server, it does HTTP 1 and 2. We're working on HTTP 3. That's not, even the spec's not quite stable yet, but we're getting there. It works over non-blocking I/O, so you can solve the C30K problem where you have so many connections, you don't throw a bunch of threads at it. It's fast, as it's written in C. We've done a lot of work to make sure that it's correct, encoding stuff in the type system where possible, and really following what the HTTP specs point out. And it's highly tested. It's been developed and used for, I went and checked, a little over 6 years now. And in that time, we've grown to have many people using it. I listed just some of the larger people making use of this: AWS, Buoyant, Discord, the chat platform, Google, Microsoft, Mozilla, plenty more that I couldn't fit on the slide, but we see a lot of usage. And the great thing is that means that we find a lot of edge cases. What one company may be using it in a special way that many people aren't, or have customers that are using interesting or rare parts of the spec. And so that really helps Hyper to do HTTP correctly, right? But so on to the point of all this, getting Hyper like as a backend into cURL. Why would we do this? Josh mentioned the zoomed out reasons, but I'll mention a few of the benefits that I see them for cURL and for Hyper. So as mentioned, cURL is everywhere, right? But it's written in C and written by humans, as far as I know. So even the best humans sometimes have memory safety bugs. And that's the idea behind Rust is, well, what if we make a tool that prevents you from making those mistakes in the first place? If we can get Hyper, HTTP library written in Rust into cURL in some ways as a backend, we can help reduce the possibility of those memory and safety errors happening in a tool that's, like I said, it's everywhere. It's like we're helping make the world a bit safer, and that's super awesome. There's also benefits to Hyper. It's not just improving cURL and users of cURL, but Hyper also gets to see some benefits. By it being used more, we get to find a few more bugs, get to find interesting ways that people are, again, using the edge cases in HTTP. And Rust users of the Hyper language or the Hyper library kind of get those benefits automatically. They just upgrade like normal, and their library, their usage is better. So what did we do? We made a C API. First of all, let me back up. I want to say back in summer or so of 2020, Daniel started poking around and asking, how would we use Hyper in a C library? Well, that's an interesting question. Hadn't really been a purpose for existing for a while, so spent some time figuring that out. The first thing we did was, well, how Rust has the ability to expose a C API, using the C API, and so we had to design that. First of all, Hyper has a client and a server, and instead of solving everything, we said, well, curl just needs a client first, so we'll figure that part out first. One thing to note, it's unstable, meaning that you explicitly need to opt in, because we're still working on this, still designing it. And so it doesn't follow the Hyper's normal semantic versioning, compatibility, all that stuff. It's possible that as we enable a few more features in curl, we might find, what, something needs to be tweaked a little bit, and so that's why it's there. Hyper, it's kind of a transfer library. Just does HTTP. It doesn't really care where your I/O comes from, and so that could be, you could run HTTP over TCP or Unix domain sockets or pipes. It could be an in-process thing, whatever. It doesn't really matter. So the C API allows you to define your I/O object, make a read and write callback, and hand it to Hyper and just run HTTP over it. It doesn't matter what it actually is. And then we modeled Rust's pull-based futures. So in Rust, the concept of futures is you pull it when you think that there's more to do, and it'll tell you either I'm ready, I'm done, or I've registered somewhere and I'll let you know when you should ask me if there's more work. It's very it's modeled similar to like ePoll or something of that nature. And so we can do the same thing with curl. And curl can decide how, if it uses select or ePoll or any other mechanism it wants to, and registers when I'm going to wake up that task again, and it works out. There was some trickiness trying to figure out how to represent and Rust futures have an associated output type. And a future will eventually become anything, and that being able to express that in C was a little bit tricky. We couldn't have this monomorphization of all the different output types into one, but we figured it out. It's basically like a void pointer and a type tag. Kind of seems like that's the way that you would do this in many other places in C anyways. And as we worked on this, and I was explaining to Daniel as he was looking in there, I'll point this out in a bit, the docs were lacking, but we started to find out that it is kind of similar to curl's multi-interface, if you're familiar with that at all. So what do we have to fix? Just about nothing. And this is a really great sign for Hyper. Hyper's handling of HTTP pretty much worked. There were a couple of features, I'd call them, that we had to add. And this is not because Hyper was wrong or that there was a bug, but more because curl has a certain behavior, and understandably, if using a different backend doesn't want to expose a different behavior to its users. Makes sense. So some of these things were like header names. In HTTP, the header name, the casing is defined as insensitive. It doesn't matter if it's uppercase or lowercase, they all mean the same thing. So Hyper takes advantage of that and forces everything to lowercase. So we don't, for performance, that means we don't have to do case insensitive comparisons or hashing all the time. It's just uniformly lowercase. And that's what HTTP 2 and 3 even require in the first place. But that would mean that if a curl user were to use the Hyper backend, suddenly if they were relying on the cases of their headers, then they'd be in for an unfortunate surprise. And then Another thing, there's this reason phrase, you know, so when you get a 200 OK or 404 not found, that phrase at the end, it's deprecated really in the HTTP specs. It's not really useful. And so Hyper just throws it away. But again, curl was grabbing that and giving it to users. So in order to not break that behavior, we added an option to pull that out. That's pretty much it though. It's like I said, that's a great sign for Hyper. But we're not done. What's a few things we still need to do? So we need to figure out how to make panics, and especially out of memory panics, which really just abort the process. That's not great. We need to get something into the standard library to allow us to override that action. So that way users don't just have a program that aborts when there's low memory. Definitely need to find a place to put the docs. So as I mentioned, Daniel was basically just had a header file and you know, banging his head against that, trying to understand what in the world we had made. So it'd be really great to find a good place to store the docs of the C API as opposed to the REST API. We also need to figure out, iterate really on the best way to generate a C library. Rust tooling does allow you to make it, but the first and primary goal of Rust was really to the creating of Rust programs. There's less things to fiddle with, less niceties when it comes to trying to produce a C library. For instance, you can't really configure the crate type at a command line. On the command line, you can't set a feature flag to control if this is going to be a C dynamic library or if this is going to be a Rust library. Some of these things would be nice to fix and improve for users, so that way they can either choose, hey, I'm compiling Hyper as a Rust library, or hey, I want the C library as well. And then, of course, it's not done in curl. Curl's still adding some features, adding some test cases. Daniel will talk a little bit more about that. And as they find things, you know, we want to make sure to fix them if something comes up, or if the design turns out, you know what, this is not a great way to pause bodies, for instance. I don't know. We want to keep working on that. And then eventually we want to stabilize. Follow semver, and then basically never have a breaking change ever again, right? That's the goal. So Hyper is open source. That means you can come join us. You can help work on it. The source code is on GitHub. Easiest place to start is just to go to https hyper.rs. You can find docs, examples, guides, and links to how to join us. And thanks so much for coming to watch us. Next up, I think Daniel is going to be presenting what they did in curl.
Yes, thank you, Sean. So yeah, hi. I'm going to talk and explain a little bit how we worked with Hyper in curl and made curl use Hyper. So yeah, I'm Daniel. I work for wolfSSL. Where am I? There. So I'm going to try to squeeze in talking a little bit. Yes, curl is C, and we work hard to make sure that we provide a stable API and ABI. And we work, curl is modular, so we work with backends to provide implementations for various things. And I converted the HTTP code in curl into an HTTP backend to be able to build and work with Hyper. Some of the challenges I had when doing this, and a little bit about how it works right now, and something about what's coming up next and what's left to do. And yes, curl is C because we started curl a long time ago, and really back in 1990. Well, I started the code actually the first time 1996, and there was really no choice than C to make a system library. And as been mentioned by both Josh and Sean, there are now viable alternatives, but they're here now. So now is the time to start thinking about that. But curl has already been in the works for 20 years, right? Or 25 or whatever. And for curl's sake, it has also been a way to make sure that it is extremely portable. It is literally everywhere. And my last count, I counted 86 different operating systems that curl has run on. And it really makes sure that it really remains everywhere. And the C code will remain a build option even now when we're adding Rust backend options. So of course, one of the fundamentals here is that we're providing a really stable and predictable API and ABI. So we are always forwards API compatible. Whatever you wrote before to use libcurl is going to continue working even when we do new releases. And we don't break the API ever. We did it last time back in 2006, and we don't have any plans to do it again. Well, that's what we're aiming for at least. And it literally exists everywhere. So every little breakage in behavior or compatibility is going to punish a lot of users, and we don't want that. So yes, you can build your code from 2001, can probably still build and run fine with the latest libcurl. So it's virtually the armored front door we can tamper with. We don't change the API, we don't change the ABI, but within curl, that's the modularity we can work with, and we can change everything. And of course, this stable API and ABI has enabled us to count around 10 billion installations of curl, and primarily libcurl then in the world. Probably more installations these days. And this, of course, curl works with backends and third parties. And when we talk about backends in curl, we talk about selectable alternative implementations. So when we provide a function, but we have different backends depending on what you want to enable when you build curl. So we have them, you can select them and deselect them. So you can, in many cases, you can actually switch off a backend completely. You can actually build curl without HTTP support if you want to. A lot of the backends are platform dependent. That means that they might not work on all platforms that curl can run on. And we often use third-party libraries to provide functionality for the backend. Like in this case, there's a Hyper library to provide support for this new HTTP backend we're talking about. And all these backends can then differ a little bit in features, licensing, and maturity even. And there's, of course, then nothing that is in the way from them being written in other languages, like, for example, Rust. And I'll get back to that. But the main point here is, of course, that the backends are provided internally. They're not exposed to the outside world through any APIs or ABIs. So users, well, they can actually figure out if the backends are used or not, but they should still behave the same. And in total, then we have the ability to build curl and use curl with a lot of different third-party libraries. In this slide, you can see all the green boxes are different third-party libraries that you can build curl to use. There are 36 of them right now. Of course, most builds only have a few of them, but the total amount. And within curl, then we have a lot of different backends to keep this modularity, so you can select which IDN system to use, how to do name resolving, TLS, SSH, HTTP3, and the stuff like HTTP content encoding, and now the HTTP core handling. And it works like this. Well, as a more of a schematic overview, we have the libcurl API fixed, the same for everyone, and we have a system for creating and reusing connections, setting them up, the TLS and everything, and we have a generic transfer engine that handles transfers generically, pretty much for whatever protocol. And of course, we have a lot of HTTP specific code. This is a generic overview of how curl looked like maybe before I started working to get the Hyper integration into this. So that green blob here, the HTTP part, was the big HTTP code that handled HTTP within curl. But HTTP itself is a lot of things. And for example, then authentication, we have to create headers, we have to handle proxy stuff, parse headers that are related to transfers and content, because HTTP is both transfer and content headers. And of course, we have HTTP1 and HTTP2 transmissions. We could also say that in curl's case, we actually handle HTTP3 separately. So I actually don't count HTTP3 in the HTTP backend because we have a separate HTTP3 backend, but it doesn't really matter. I'm focusing on that HTTP is a lot of things. And in our case, working with Hyper provides a slightly more focused, I would say, more specialized HTTP than curl itself. So curl does more HTTP than Hyper does. So it then forced me into this, well, then I decided to split up the HTTP within curl. So I just pretty much made sure that the generic HTTP code was made in one layer, and then we split it out and handle the different HTTP backends provided either by Hyper or the built-in functionality. And the built-in functionality actually is also supported by the ng HTTP2 library if you build curl to do HTTP2. So that's the backend split within. And you of course build curl to enable with Hyper enabled with this configure option with -- with Hyper and the path to the Hyper installation. And if you see the URL in the bottom here, that's the documentation. You can just go to it's in the Git repository. And if you do this, then it works pretty much like I described before. We have the API and the generic stuff, and we now have the high-level API, high-level HTTP code in curl that is split up to either work with Hyper or the built-in version. And there you select that at build time, so there you only have one of them in runtime. And another view of the entire thing then is, yeah, the application, it doesn't really know. It goes through the public API into curl, and internally we go through the internal HTTP API to the various backends. And just to give you then the wider view of all the backends in curl, that's a lot of different backends that they're all provided. They all provide functionality to curl via these different internal APIs to make sure that we remain a solid and stable API to the applications and the outside world, basically. So this was, of course, there were some challenges involved in doing this to get Hyper work like this within curl. So, well, of course, exactly like just as Sean explained, we're the first user of the Hyper-C API because it didn't exist when I asked for it the first time, and now it exists. So yes, I had to work with headers only without any particular documentation, but I had the best resource because I could ask Sean directly, and he was the great. It was great documentation. So it works out really good anyway in the end. But it just had to. We had to have a few back and forth for me to actually understand exactly how it works. But it's a really good fit because they have a really good model that works really good with curl internally, and we have the same view of a lot of things. So I had to do that, splitting up the HTTP stuff internally, as I just explained, and we can now keep the behavior. And we Hyper has quite a different API paradigm than libcurl exposes to the world, but it doesn't matter because we managed to hide it pretty good. One little thing is, of course, that thanks to the API and this being the C API and stuff into the Rust engine there, when I forget to free something that I should have done using the C API, it gets a little tricky with memory leaks. Who's responsible for it and which call did really leak the memory? But memory leaks are always tricky. But the fact is that yes, it is a Rust underneath somewhere, but I don't have to care about it. As a user of this, I don't really have to care about it, and it doesn't matter. And especially if someone who's using this, it won't notice. And yeah, it's just in there. And I could also then highlight that this is not even the first Rust library that curl can use, because curl can already, since before, get built to use other Rust written libraries. So more Rust in curl going forward. So right now then what works with Hyper in curl is that you can build, right now if you go to Hyper, if you check out Hyper or curl from Git, and you can build it, and you can build curl to use Hyper as is right now. Sean mentioned how Hyper is unstable in their repository, and in curl we have basically the same approach, but we call it experimental, which is a feature. It's a label we put on things that are basically not set in stone yet. So it might actually change before we remove the experimental label. So we discourage people from using it in production, and we might actually break some behavior going forward if we have to. So you can already now then do both HTTP1 and HTTP2 transfers, and you can build curl to use any of curl's TLS backends, and curl supports since a few days ago 14 different TLS backends, and you can even go with a Rust written backend nowadays, since we merged support for Rustls just the other day. So you can select to go with even more Rust by enabling Rust-enabled TLS backends if you want to, and it works fine with this Hyper backend because they're totally independent of each other. You can it also works with both HTTP and HTTPS proxies, and the HTTP requests over the wire are identical. So that's one of the things that Sean mentioned that they had to fix, because I wanted it to make sure that we could run the tests exactly as they are for the built-in HTTP backend as with the Hyper HTTP backend. So and in the curl test cases, we compare the HTTP requests byte by byte, so we can actually be very sure that the requests are indistinguishable from each other. I mean, depending on, you can't tell which backend that is used by looking at the HTTP requests or the responses even. So right now we're at I think we're at roughly 95% test case success rate, and there's around 800 test cases for HTTP related stuff. It might be so that the more difficult things are what is still left to fix, right? But if you go with simple things, ordinary HTTP things, get post, rather ordinary cookies, authentications, proxies, all that works. When you're going into edge cases, we still have work to do. So going forward, what is there to do, and how are we watching things? So of course, my primary goal here is to make sure that all test cases actually succeed, so that we can run this with a better success rate and make sure that we add this to the CI tests and everything going forward. And to do this, we have to make sure that we verify some of the more corner cases in the API that libcurl supports to users that might be tricky to actually go all the way through down to Hyper. And of course, we encourage users and anyone to dive in here, enable this in the build and go use it and try it out and tell us how it works and what start fixing things to make sure that it actually gets really solid. And I'm hoping that we soon will be able to provide binary builds for those of you who want to try this out without building it yourself. So the question is then, of course, will anyone enable this by default somewhere soon? And I really cannot tell because I don't know. I work with curl. We provide curl as source code to the world, and I hope that by providing this as good as possible, and when we make sure that it works really good and solid, that should be the enable people or distributions and operating systems to take that decisions by themselves eventually. And of course, this is open source and you can help, and you're more than welcome to dive in, try this out, and submit bug reports or pull requests, and let's help out to make this even better. And if you have any problems with curl, we provide commercial curl support at wolfSSL, so get in contact and we'll help you out. That's all I wanted to say about this today. I see that we have at least one question in the Q&A thing here.
Alrighty, we have a question right here from Lucas. What are the ideas for making better C documentation? Quiche has a similar gap between REST API and C API documentation, which also hurts Daniel.
Yeah, so I'll start a bit. I mean, first of all, I don't really write C libraries. So what is usual for writing documentation, like if there's systems to, I don't know, I see curl has excellent web documentation. I don't know if that's custom or if there's a common way to do it. In my mind, I wrote up an issue over on Hyper that I was thinking, well, I'd probably just take the C API and produce the Rust docs with the idea of the audience who's reading this, hey, this is actually the C that you would write with code examples. And then it would just live right next to the Rust documentation. But maybe there's a better option. You know, if you have one, that's awesome.
Right. Yeah. In my case, this goes back a long time, but I've always, as a more as a personal opinion, always had trouble with everything that generates documentation automatically from header files and stuff like that. So I've never done that in curl. So the curl, everything that is curl, the documentation is generated from the man pages from curl that we write them manually.
Right. Yeah.
So I really can't tell how anyone else is going to do it, but that's how we do it. So basically just maintain a separate document in whatever format we think is good. That can be used to generate good web pages, basically.
Mm-hmm.
Do you recall any of the edge cases that Hyper had issues with? Question from Evan.
I don't. Daniel, maybe you knew some that I don't know about yet.
No, I mean, I think it goes back a little bit to since the edge cases I had was more edge cases that are like Sean already mentioned, that was stuff that decisions the Hyper project has made and compared to how we do it and assume things for the test suite in curl. So for example, we have the line endings in for HTTP headers and stuff like that. So otherwise, I know, and that stuff with the reason in HTTP responses and stuff like that. But they were more subtle details in how we get data in and out of the. They weren't really related to the protocol. So right now, I don't think we've seen any problems. And I think actually it also. It's thanks to Hyper being rather focused and I would say rather narrow in its HP implementation. So for example, all the authentication stuff is still done by the upper layers in the HP handling in curl. So we didn't have to go down that route. So no, it's been pretty straightforward.
Awesome. Is there a speed difference between the different backends?
That's a good question. I know I tried it out a little bit, but I haven't actually done any proper benchmarks, and I'm not sure how to do it. That would be relevant and interesting. So but I think it would be fun to do it eventually and see if it's measurable at all, and if it is, why, and work on that. Because if we can measure the speed difference, I think that would be an interesting thing to address. Actually, I mean, either direction.
Yeah, I remember you when you were trying it out, you were like, hey, Hyper is 300 times slower or something like that, and we found, oh, that's because by default it's using the debug form, which does no optimizations at all. But
exactly, yeah. But once we had that fixed, it was sort of comparable. I don't remember, but it was basically the same.
Yeah.
In that test.
What advice do you have for other maintainers who are looking to adopt Rust?
Well, for me, I haven't really. I think it's really easy for me because I haven't really adopted Rust. For me, it's just a way to make sure that I can support this feature via another library. And for me, it doesn't matter if it's, as a user of this, I don't actually have to care about it being Rust or not. I mean, as a more pragmatic view, of course, I want to make sure that it's good and reliable. But so for me, it's more important that it actually has a good API and a good solid that I can rely on it and trust that it actually works the way it does, and that I can understand how it works, and it doesn't crash, it doesn't leak, and stuff like that. And so then it's really easy to go with Rust. And I think it's also without telling how Sean has experienced it, it seems rather easy for Sean too to provide this C API. And so, has it been hard to do the C API, Sean?
I mean, there was work involved. Some of it was not really being experienced with providing C libraries. I've been working in Rust for a long time now, and that translation was tricky. And I already also mentioned some of the things with providing like a Rust library and C library, and the compiler options they could be improved.
Right, but that's more exactly right. Infrastructural things in
Yeah.
your end. Yeah, I agree. Yeah. So.
Another question related to Rust. Do you think that curl will ever be rewritten in Rust?
Ever is a very long time.
Yeah.
So no, I wouldn't ever say ever, but it's not likely to happen anytime soon. And I think this way of doing Rust in curl is the way to go. So if we would ever rewrite it, I would say we would replace every component one by one until eventually we don't have any components left to replace. But I would imagine that's pretty far off.
What would it take to run curl or hyper from a server-side WebAssembly with no browser present?
I'm not quite sure what that's asking. Server-side WebAssembly. I haven't done WASM that much myself. I see people telling me reports like, hey, they're running Hyper's HB2 component in the browser. It says no browser present. I don't know. I don't think I could easily answer that one. Sorry.
No, me neither. That's really not my expertise either. So no, sorry.
Is Hyper being started with default Tokyo runtime parameters?
Right. So Hyper provides the ability to work with the Tokyo runtime, which is a networking runtime in Rust. But it also has the ability to turn all of that off and allow the user of the library to bring their own event loop runtime thing. And so that's what we've done with curl is they just assume that they also have the same thing where the user can bring their own runtime and you fit into it. And so Hyper doesn't enable that stuff by default because it assumes the user is going to pick that stuff.
Yeah, so exactly. So Hyper fit really good into that model. So in curl's case, we can the user can provide the entire main loop select thing really, and so curl just acts as a little middleman there, and Hyper fits perfectly into that.
Awesome. Is ISRG working on any other memory safety projects?
Yes, we are working on them. So curl was our first one. The second one we've announced is a replacement for an Apache module called modSSL. So Apache is also, the Apache web server is also a modular system, and they use modSSL to provide SSL and TLS functionality. So we have an Apache committer working on creating a new module called modTLS, and that module uses a Rust-based TLS library instead of OpenSSL. So OpenSSL is quite ubiquitous, but it's written in C, and this has caused numerous horrifying problems in the past. And there's no reason to believe that those aren't going to just continue happening. So we're making a new Apache HTTPD module that uses a Rust-based TLS library. And we'll be announcing some more work soon. One of the most exciting developments in the world of moving critical systems to Rust has been some work that Alex Gaynor has been doing to get Rust into the Linux kernel, and we are following that closely.
Awesome. Is the C API to Hyper now a fixed part of Hyper, or is this an example for other Rust components to follow?
A fixed part of Hyper. I mean, it's part of Hyper. Like I mentioned, it's unstable. So, you know, maybe we find out that it's not easy to completely fix the compiler to do those flags back and forth, and so maybe it has to be pulled out again. I don't know the answer to that. We'll figure that out as time goes on. Is it an example for other Rust components to follow? Maybe. I hope so.
Awesome. This question specifically for Daniel. Have there ever been other efforts to integrate other backends written in the memory safe languages that are not Rust, perhaps other functional languages into curl?
No. Well, no, I don't think so. I mean, we also actually support backends provided by proprietary libraries, and those are theoretically written in whatever language, so we don't even know. Like we have support TLS libraries on the OS 400 platform that I don't even know how they write it. They probably don't write it in C, I don't know. But no, the more mainstream ones, they're all Rust written, the memory safe ones.
Awesome. How is Hyper's HTTP3 work going, and how do you think curl will accommodate that once it's ready?
Yeah, it's some of the community members have done a much better job than I of pushing on this, and it's so the H3 component that is not part of Hyper yet. We got a working client and server, so we can connect to Quick.tech and Cloudflare and Cloudflare's blog and stuff like that, which is awesome. There's the tricky part of, since it doesn't run over TCP. And you kind of need to figure it out perhaps through an alt service header or something like that, that it doesn't fit just as easily as HTTP2 did over HTTP1. I don't have that part squared away yet, so I'm not sure yet how that would fit into curl as well. But
right, because we can't abstract that the same way, so we have
right.
to have some yeah, slightly different at least.
Mm-hmm. Yeah, it doesn't even fit like the exact same IO thing. It's no longer just a read and write, but it's UDP.
Exactly. So yeah, exactly. So yeah. Well, Lucas asked the question. He knows all about that.
Alrighty, and now this is our last question. Are all of ISRG's memory safety initiatives based on Rust, or are there other ways to achieve memory safety?
You know, Rust is a really helpful language for memory safety because it doesn't have a runtime and it interacts very well with C and C++ code. There's very little conflict between the two. However, you know, we're going to end up using a lot of Rust, but we're not stuck on Rust as the only answer. For some projects, other languages will make sense. There are a bunch of other great memory safe languages out there. But Rust is going to feature heavily in any kind of evolution of C and C++ infrastructure. So we're not tied to Rust. It's not always the right answer, but when you're looking at fundamental internet infrastructure that's written in C and C++, it's going to be the answer a lot of the time, especially if you're talking about moving C projects component by component instead of just rewriting something.
Yeah, I think that's a key part to this type of project, right? That they can actually be like this component by component, and then you have to be rather close to the C way of doing things, like Rust is. So, I mean, and even as Sean already explained, even Rust is not completely there with all the parts. So I think Rust is one of the ones that is actually today a real alternative, right? And there are other memory safe languages, but they're usually not that close to C, and much more work to actually integrate like this.
Yeah, actually an important part is how many of the ways that things are memory safe is they bring some sort of garbage collection, which involves a runtime and stuff. Rust just works the same way that C does, basically.
Alrighty, and we are now over time. I'd like to thank Sean McArthur, Daniel Stenberg, and Josh Aus for a fantastic presentation. I would like to also thank everyone for attending. I invite everyone to follow us on Twitter at wolfSSL and at ISRG, as well as all of our other socials. And this is a reminder that this webinar is also recorded, and we will post to our YouTube channel shortly after this presentation. And if you have any questions, please feel free to email us at facts@wolfssl.com, and we'd love to answer any additional questions you may have. Thank you.
Thanks. Have a good day, everyone.
All righty, bye-bye.
Thank you. Bye.